Hello, everyone. We are Group 12 presenting our progress on the Boomer project. Boomer is a card game that is an extension to the popular card game Uno with a few extra rules. We're going to demonstrate our client server architecture for the application. We have made the client UI and logic using Unity. The server is made using Node. Currently, the server is mainly used for storing the game state. The client and the server communicate using WebSockets in our application. And now we will go into more detail about the setup with the client talking to a server.
I'll be walking through the front end of our game. I'll explain the game objects, the scripts, and how the client communicates with the server. So we have our game objects here. Discard pile is the object that holds the cards the player has played. And draw pile is the deck of cards that a player can draw cards from. And player cards is where the player's hand is displayed. The game manager is an empty object which has the game manager script attached to it. Now let's look at the scripts. Card CS defines the properties of a card, such as its type, its value, color, and visual representation. Drag drop script allows the player to drag cards from the player's hand and drop them onto the discard pile. And the game manager initializes the game and it handles communication with the server and it updates the game state based on what the server responds. It sends and receives messages using WebSockets. Now we'll move on to the backend of the system.
For the backend, we were planning to use a passive replication architecture, where the s- the where we'll have a leader server and we have several replicas of that server. And right now we are like focusing on the leader server for now, and on the next sprint we'll try to do two more so that we have three working servers. Right now on that server we have like a primary queue called a message queue that will actually store the message in a FIFO order, first in, first out, right? So then we'll already have the order of events already synchronized, so we don't really need to use totally all the broadcasts, like in say in active replication, for example. However, we'll use TOB just to synchronize the data of each servers, so that they have like they are like accurate across all the servers, right? Now let's move on to the actual code itself. Um, so here we have a message queue that will actually store all the events, right? On the server side, we are using WS for the socket library, and then um when we're storing all the events in the message queue, we also have this value here is processing. Well, actually force each request to kind of like be like a one at a time. So like it's kind of like blocking. So we kind of like also implemented a blocking system where the ones that are blocked are stored in that queue. And then when the currently process is already done, then the next one in the queue is going to be processed. For the client, for the game manager, we've used native WebSockets to do like the connection to the backend, and also uh for the in that also like let me just show you guys like the interaction as well. So like those are we kind of like made it just like comments for now, and later we'll probably store the values in the game state. Um, so right now it shows like we're sending the deck to the server, we are sending the player cost to the server. We've connected to the actual server as a player, and here we are actually sending a message. Like we actually receive a message from the server that says like welcome to Uno server. And if we draw a card here, for example, you'll actually see there was like a processing message of draw card here. And on the server side, it also said like you drew a card. Um, yeah, that's it for the client server interaction. Thank you for listening to our presentation.